NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
After 45 years of journeying through the vast expanse of space, Voyager 1 has made a discovery that defies all expectations. What could this groundbreaking find mean for our understanding of the universe? Buckle up as we delve into the astonishing revelations from humanity's most distant explorer. This is not just another space story. This is the impossible come true. Voyager 1, launched by NASA on September 5, 1977, is a pioneering space probe designed to study the outer reaches of our solar system and beyond. Initially part of the Voyager program, alongside its twin, Voyager 2, Voyager 1's mission was to explore the outer planets. After successfully sending back detailed images and data from Jupiter and Saturn, including their moons and rings, Voyager 1 continued its voyage into the unknown. In 2012, Voyager 1 achieved a historic milestone by becoming the first human-made object to enter interstellar space, crossing the heliopause, the boundary where the sun's influence wanes and the interstellar medium begins. This incredible journey, spanning over 4 decades, has taken the probe more than 14 billion miles from Earth, providing invaluable insights into the nature of our solar system's outermost regions and the interstellar environment. So, let's get into the topic. So we've got something truly fascinating to share about a weak but persistent signal from the Voyager 1 spacecraft. At first, it seemed like a fluke to Cornell University PhD candidate Stella Koch-Ocker. I was literally just kind of staring at a plot, and I thought I saw something really faint, Koch-Ocker tells Inverse. And I was like, am I starting to see things? She wasn't. In a new study, Koch-Ocker and her colleagues report a new signal coming in from the plasma wave system instrument aboard the craft. They used these observations to obtain a new measurement of the density of the interstellar medium, the thinly distributed mix of molecules, atoms, and ionized gas, or plasma, that fills the space between stars. The research, published in the journal Nature Astrophysics, provides the first continuous measurement of the density of the plasma in the interstellar medium, which previously had only been known in isolated spots. By looking back at the last 3 years of observations from Voyager 1, the researchers were able to assemble consistent measurements of this elusive interstellar plasma. They continue to monitor it as Voyager 1 speeds out of the solar system at more than 38,000 miles per hour. It is approximately 14.1 billion miles from Earth. What's new? Prior methods of measuring the plasma density relied on picking up strong, intermittent bursts of signal from Voyager 1, which seemed to occur about once every year. The intermittency of the signal made it akin to a once-a-year massive storm of large plasma oscillation events. Emerging in data taken from 2017 to 2020, the new signal is only a few times stronger than the sensitivity of the instrument, making it barely noticeable. The plasma wave system allows Voyager 1 to measure vibrations of plasma at specific frequencies. The newly detected signal is a low-frequency hum at roughly 3 kHz, and rather than being associated with intermittent events, the signal came across steadily over the entire duration of the 3 years, with little change in its character. When we looked between and below these plasma oscillation events, we found this very weak, persistent signal of plasma waves that appears to not be related to solar activity, says Koch-Ocker. The continuity of the new signal means the researchers can produce measurements of plasma density all along the trajectory of the spacecraft. Discovering this trickle in the furthest reaches of space was almost entirely unexpected. Here's the background. Voyager 1 is one of 2 groundbreaking NASA missions launched in 1977 with a mission to explore the outer planets of the solar system. Voyager 1 and 2 have obtained stunning pictures and information about the cosmos and have both been in continuous contact with Earth since their launch. Voyager 1 is the most distant human-made object in space. To accomplish these feats, mission planners took advantage of a particular alignment between the planets that happens only once every 175 years. This alignment allowed the spacecraft to consecutively slingshot between them purely through the use of natural gravitational forces. After their main missions ended in 1989, with Voyager 2's encounter of Neptune, the craft were both transitioned to an interstellar phase on their path out of the solar system. In 2012, Voyager 1 reached interstellar space, an area no longer dominated by the influence of the Sun. Physicists always expected there to be tenuous plasma out there. Plasma is a phase of matter formed when a gas is heated so hot that its atoms and molecules are torn apart into their constituent ions and electrons. In the region of space closest to us, our solar neighborhood, plasma is formed with distinctive characteristics from the heat and radiation of the Sun. Space isn't a true void. It's filled with stray molecules of gas and solid matter, which get turned by the Sun's heat and radiation into plasma. Outside this bubble, known as the heliosphere, the plasma of the interstellar medium was expected to take on alternate characteristics. Voyager 1 showed exactly how. How did they do it? Prior to Voyager 1, researchers could only get clues on the interstellar plasma from observations with distant telescopes. But once Voyager 1 passed beyond the heliopause, separating the Sun's neighborhood from interstellar space, it began registering direct signals from the plasma. These signals came in the form of occasional bursts of strong electrical discharge. The bursts were detected by Voyager 1's plasma wave system, one of the few instruments still operating on the craft. The spacecraft had a more robust plasma spectrometer that was defective on Voyager 1, though the one aboard Voyager 2 is still functioning. Scientists gradually put together a picture of these signals as being caused by shock waves that occasionally barge out from the Sun, making the plasma in the vicinity of the spacecraft vibrate, which in turn causes oscillations in its electric field. However, when analyzing the overall electrical measurements collected from 2017 to 2020, researchers discovered a weak yet smooth signal hiding in the background of the data. Though this signal has the same fundamental electrical nature, it is more like a constant pitter-patter rather than the occasional rush of a storm. Both the strong, intermittent signals and the weak, steady signal provide important information on the nature of the interstellar plasma. In particular, the way that the plasma's electric field fluctuates can be traced back directly to the plasma's density. Previously, researchers could only estimate the plasma's density during the solar shockwave events. Moreover, the researchers find that the new density measurements are consistent with the old ones, having the same values when they were measured at the same time. It's pretty incredible how a mission that's so old can still produce such exciting new discoveries. The new results allow the researchers to turn a spotty record of plasma density with year-long gaps into a smooth, consistent record over space and time. The researchers find variations in the density with characteristic scales of 1 astronomical unit, AU, the distance between the Earth and the Sun. These variations have long been expected to arise due to turbulence in the interstellar medium. Thanks for joining us on this incredible journey through the cosmos. Don't forget to like, subscribe, and hit the bell for more mind-blowing discoveries from the final frontier.